Our goal for today is we are going to be rewriting and evaluating expressions using log. So our goal, of course, is we're going to be evaluating an log. However, before we can do that, we have to understand what log is. What the Gehenna am I talking about here? So by introduction, let's take a gander here. What's the inverse of plus 2? How do I undo a plus 2? Minus 2. There we go. So that's it. Nothing complex about that. Just minus 2. Same thing over here. The inverse of subtract 16 is add 16. Over here, the inverse of multiplication is division. Divide by 4. Over here, I multiply by 3. Now, of course, it's not as simple as this. Generally, there's another side of an equation, so whatever I do to one side, I do to the other. But the idea behind it is I'm just analyzing how do I undo a multiplication? How do I undo a division? All right. We know how to undo this. So this one is not as complicated as you might think. When you square root, those two pretty much annihilate each other. So G is by itself. What up, G? Okay, what about this one? H cubed. Little bit more complicated, but that one's actually called a cube root. We actually haven't seen that at all, but that's the exact same as a square root, but you just put a small little 3 on the inside of the check mark.
Can you do that? How does that work?
You can do that to the power of 4, to the power of 5, to the power of 6. We just call it a 4th root, 5th root, 6th root, etc.
A 5th root would be like...
And of course, we can take this to the next level here. To undo the square root, we square. So how do we handle 2 to the b power? Do I divide by 2?
That's a good one.
Now if I divide by 2, I have to subtract the exponents. So that gives me b minus 1. Can't be that. Do I take the square? No, square root just means I take the b and divide it by 2.
Square b.
So do I take 2 to the b to the square?
That's just absurd, Jeremy.
You can take exponents of exponents of exponents. That's a complete possibility. So how the Gehenna do I get the b out? Because before, if I had this b squared, oh, that's no problem. I get rid of the square by square rooting. But how do I get b out from the exponent? How do I get b out from the exponent? So that's the big question today. So here we have the magnitude of an earthquake is a measure of the amount of energy that's released. Kind of like TNT. How much energy is coming out of the earth? So not how much something is shaking, but how much is being released. Kind of like how bright a light is. This is about how much energy is being released. So the Richter scale measures the magnitude of the earthquakes by using the exponents. An earthquake of magnitude 5 releases 30 times as much energy as a magnitude 4. Where does that come from? Well, here we call, it's a 4.0. Well, what is that? It's the amount of energy times 30 to the 4th power. So an exponent, or a 5.0, would be 30 to the 5th power. So notice, going from here to here is multiplying by 30. So going from here to here is multiplying by 30. So that means if you are in a 4.0 earthquake here, and later you're in a 6.0, it's not 2 bigger, it's 900 times bigger, because 30 times 30. So a 4.0 compared to a 7.0 is 27,000 times greater. So I have been in an earthquake here at a 6.4, and the most recent one in Nepal is 7.8, which is about 1.5 on the Richter scale, 1.5, but that's going to be somewhere about 164 times greater than I experienced. All right, so that's where we get the idea of Richter scale. We're using the exponents themselves. So let's define something and look at exponential form. So we're very familiar already with this, where we have a to the b power is equal to some number. a to the b power is equal to some number. So for example, we'll write this one out as 2 to the 4th power is 16. That's a true statement. But of course, we were trying to figure out how do I get rid of, or how do I get to the b? How do I get to the exponent from the position that I'm in? So for example, if I had an x right here, how would I undo that? Well, let's just refresh real quick. This right here is called my base. The big number is my base. This number here is called my exponent. And of course, the equal to is your equal to. All right, so how do I rewrite this? Well, we use this idea of a logarithm, or we simply say log. So instead of saying logarithms, we just say log. All right, so what you do is you have your log with your base here, then the number that it is, and then your exponent is over here, and that's a b. In other words, log of a of y is equal to b, or log 2 of 16 equals 4. So it's kind of like a question. So here we can rewrite to say log 2 of 16, and that over there should be a y, I'll change that, is equal to 4. And that's a y. All right. So the question kind of goes like this. If I take 2 and I raise it to some power, I get 16. So 2 to what power is 16? So that's how we rewrite log here. In other words, look, I got my exponent by itself. 4 is by itself. B is by itself. So we have to rewrite the log. Sounds a little confusing at first, but once we get into the groove of things, it'll go a little bit faster. So how about this first one here? How do we rewrite this? Well, this one here says 3 to the 4th power is equal to 81. 3 to the 4th power is equal to 81. And notice that in this context, it starts out true. This is a true statement. And over here should be true too. 3 times 3 times 3 times 3 is 81. Oh, great. It works out. So being able to rewrite in both directions, I'll skip down to CE here. So this one here, 9 to the 1 power is equal to 9. Or this one here, 1/4 to the negative 1 power. So I'm putting all of this in parentheses. To the negative 1 is equal to 4. And this one here would be 4 to the 0 power is 1. 10 to the negative 2 is 0.01. And 7 squared is 49. So that's rewriting it into exponential form. This is called the logarithmic form. This is called the exponential form. And we do need to be familiar both directions. Both directions. So let's look at evaluating log without using a calculator. But before we do that, we need to know two small properties. B is a positive real number. So B here is the base there. And B does not equal 1. Because 1 to any power pretty much is 1. So it doesn't really help to have B being 1. Okay, so if the log of B of 1 is, that will always give me what value? How do I get a 1 by raising B, something to a power? Raising B to what power gives me 1? The answer there is 0. Because anything pretty much to the 0 power is 1. And how about this? I have B raised to some power will give me itself. Well, that one's going to be just 1. And the reason for these is because this one is an exponent. B to the 0 power is 1. And this one says b to the 1 power is b. So that's the logic behind it. So if you do notice that the base, and again, when I say base here, I mean the small little number next to the log. Base, if these numbers are exactly the same, then they pretty much cancel each other out. It's kind of like inverses here. A quick note. Common log is called this. We just say log. And when log is just written like this with no small number, that means log to the 10 of 10. That's called the common log, because 10 to some power will give me some other number. And since we use 10 a lot, it's called the common log. All right, so let's evaluate this expression. So on A here, we have to ask ourselves this question. 2 to what power gives me 64? 2 to some power gives me 64. 2 to some power is 64. That's what we're saying here. So we just think about it for a little bit. 2 times 2 times 2 times 2 times 2. So in the end, we can say that x is equal to 6. Why? Because 2 to the 6th power is 64. And we could have just done that with our calculator if you didn't know it already. So what does b mean? It means I have 1/2. I'm raising it to some power, and I'm going to get 1/4. So what gives me, how do I get from 1/2 to 1/4? Well, if I square it, so x is 2. Why? Because 1/2 squared is 1/4. 1/2 times 1/2 is 1/4. This next one, if I rewrite this, I have 1/3 to some power, and that'll give me 27. So how do I get from a fraction, 1/3, to a whole number like this? Well, I need to reciprocate it, so x definitely needs to be negative. So I have to flip it. And how do I get from a 3 to a 27? What exponent needs to happen?
9.
3 times 9, good. But how about 3 to what power? 3 to the 3rd power. So notice here, -3. Why? Because 1/3 to the -3. The negative means flip the exponent, or flip the fraction, so this becomes a 3 inside, and the exponent stays 3. And then 3 times 3 times 3 will give you 27 there. And the last one here, how about this? In other words, 4 to what power gives you 2? So how do I get smaller? How do I get smaller? Well, x is actually 0.5. In other words, you could also say this, x is 1/2, because it is the square root. Now, we haven't talked much about exponents being fractions, so we'll unpack that later. We just want to introduce that right now.